Kepler has given us three laws regarding the motion of planets. All of you know that. The first law, which is also called the law of orbits, it states that all planets revolve around the sun in elliptical orbits with the sun at one of the foci of every planetary orbit. The second law, which is also called the law of areas, it states that the line joining the planet and the sun traces out equal areas in equal intervals of time, or the aerial velocity of a planet is constant. The third law, which is also called the law of periods, it states that the square of the time taken by any planet to complete its orbit around the sun is proportional to cube of the semi-major axis, or the average distance of the planet from the sun. We have studied these laws are based on the observations of Tycho Brahe. They are not based on any theory. We have learned these laws without having any doubt regarding these laws. Newton, as a student, when he came across these laws, he wanted to know why the planets behave like this, why their orbits are elliptical, why the aerial velocity of any planet is constant, and why the square of the time taken is proportional to cube of the semi-major axis. During that period, an epidemic spread in London and his college was closed. He went to his native place. His house was in a farm. One fine morning he was sitting under an apple tree with that problem still in his mind. When he was deeply involved in this problem, he just observed an apple falling before him. Many apples might have fallen before him many a times, but at that moment he just paid an attention on this falling apple, why the apple is falling down. Then by his intuition he got an idea that perhaps the earth is attracting the apple, as a result it is falling down. Then he thought whether earth attracts only the apples or other objects also. Then he extended his knowledge to other objects present just above the surface of the earth. After that, he has extended it further to cover the moon and the sun. Then he got an idea that all the bodies in this universe, they attract one another. This is called gravitation. You might have come across the word gravity. Gravity is the gravitational force exerted by the earth on other bodies. In general, the force between any two material bodies is called gravitation. He got a law called Newton's law of gravitation. How he has derived it, we'll consider at some other time. Now let us discuss Newton's law of gravitation. According to him, if two objects of masses m1 and m2 are separated by a certain distance, they exert force on each other. The force depends on mainly two factors. One is the product of their masses. Second one is the distance between them. It states like this: the force between any two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance. Strictly speaking, this law is valid only for very small sized objects, which we call point objects. It can be applied to extended objects, provided they are spherical in shape. If they are of any other shape, then this law cannot be extended. Suppose we have got two bodies of masses m1 and m2 separated by distance r between them. Then body m1 will experience a force due to the second body. Suppose it is f12. Body 2 also will experience a force due to the first body. Suppose it is f21. Whatever may be the ratio of their masses, whether they have got equal masses or different masses, the forces on them will always be equal and opposite. This we say action and reaction. Then you may get a doubt which occurs first and which occurs afterwards. Whenever we say action and reaction, it means it is a pair of forces which occur at the same time. In our daily life, suppose you are quarreling with someone, if someone hits you, that is called the action. If you beat him afterwards, that is called the reaction. It is not like this. Both the bodies will exert the same force at the same time. No one is first, no one is afterwards. If you consider a pair, the earth and the sun, which attracts first, both attract each other at the same time. Okay, these forces are equal and opposite. So we write F12 is equal to minus F21. It is independent of the ratio of the masses. Now let us come to the Newton's law of gravitation, which says that the force is proportional to the product of the masses and inversely proportional to the square of the distance. On combining these two, F proportional to m1 m2 by r square. Usually we replace the sign of proportionality with sign of equality. Suppose here the sign of here we take constant g. This constant g is called gravitational constant, or it is also called universal gravitational constant. First of all, let us see what it is and what is its value, what are its units and dimensions. Okay, to understand this one, what is g? We rearrange these quantities. We write this equation as g equals f r square by m1 m2. Here we make some supposition that m1 is equal to m2 is equal to 1 kg each and distance r is equal to 1 meter. Then what remains here? G is equal to f, because it's 1 square, 1 and 1, g is equal to f. That means the gravitational constant is nothing but the force of attraction. When we take two bodies, each of mass 1 kg separated by distance 1 meter. This is gravitational constant. Its value was first measured by Cavendish and he got it as 6.67 into 10 to the power of minus 11 Newton meter square per kg square. How we got this unit? From this formula. F has unit Newton, r square means meter square, kg is kg square in the denominator, so we write it as kg to the power minus 2. On substituting the dimensions of these quantities, we get the dimensional equation of g as m to the power of minus 1 L cube t to the power of minus 2. Gravitational constant is the only quantity in first year syllabus which has got negative dimensions in mass. Suppose you get a question like this: which of the following quantity has negative dimensions in mass? It was asked many times. Answer is gravitational constant. Suppose it is like this. First one is viscosity, surface tension, gravitational constant, Boltzmann constant, whatever it may be. The answer is gravitational constant. Then you may be having a doubt whether this is the only quantity which has got negative dimensions in mass. In second year syllabus, you have got two more quantities. One is capacitance, another one is permittivity. Both these two quantities also have got negative dimensions in mass. Suppose you got a question like this: which of the following quantity has negative dimensions in mass? Capacitance, permittivity, universal gravitational constant, all of the above. Now the answer is all of the above. Or you may get a question like this also: the gravitational constant of the dimensional equation of gravitational constant is given like this: m to the power of a, l to the power of b, t to the power of c. What is the value of a? Minus 1. What is the value of b? 3. What is the value of c? Minus 2. Or it may be asked like this also: what is the value of a plus b plus c? A plus b plus c, the answer is 0. So now we understood what is g. This is called universal gravitational constant. This is because it is same at all places in the universe. Not only in the universe, even outside the universe also the value is same. The value of g is same at all places. Therefore, it is called universal constant. Since it is pertaining to gravitational, it is called universal gravitational constant. I hope it is clear to you. Now let us take some simple things here. What about the accelerations of these bodies? What about their velocities and so on? Suppose we have got two bodies of masses m1 and m2. What is the ratio of their forces? Force ratio of forces is F12 is exactly equal to mod F12 is equal to mod F21. Whatever may be the ratio of the masses. Suppose we said that we have got two bodies, one of mass 1 gram and the other is of mass 10,000 kg. Which will exert greater force in that pair? Both will exert equal forces. Suppose we say we have got one small body of mass 1 milligram, another of 1 million kg. They are separated by a certain distance. Which will exert greater force? Both will exert equal forces. Now, since they are experiencing equal forces, we may get a doubt, perhaps they may be having equal accelerations also. No, that is not the case, because force is equal to ma, a is equal to F by m. If masses are different, accelerations will be different. So here m1a1 is equal to m2a2, or a1 by a2 is equal to m2 by m1. The ratio of their accelerations are in the inverse ratio of their masses. Suppose we have got two bodies of masses in the ratio 1:2. If they are separated by a certain distance, what is the ratio of the forces? 1:1. What is the ratio of the accelerations? 2:1, inverse ratio. Now here we may get a doubt, because they are moving with different accelerations, the center of mass will be having some acceleration. Now let us find what is the acceleration of the center of mass. Even though the two bodies have got different accelerations, their masses are also different. What is the formula for the center of acceleration of the center of mass? AC is equal to m1a1 plus m2a2 by m1 plus m2. We know that F12 is equal to minus F21. So F12 plus F21 is equal to 0, or M1A1 plus M2A2 is equal to 0. 0 by anything is 0. If we write the magnitude, we write it like this. If we write full vectors, then we have to write minus here. Then M1A1 plus M2A2 is equal to 0. So like this, the acceleration of the center of mass is 0. The sum of the pairs of two forces involved is also 0. Or you can say it like this: since the external force is 0, the acceleration of the center of mass is 0. Now let us consider one more thing. Suppose these bodies are released. They are under mutual attraction. They start moving towards each other. So at a certain instant, suppose it has got velocity v1, this has got velocity v2. Because they are moving in opposite directions, their momentum will be opposite. Since total momentum is 0, m1 v1 is equal to minus m2 v2. Or m1 v1 plus m2 v2 is equal to 0. Just as here m1 a1 plus m2 a2 is 0, m1 v1 plus m2 v2 is also 0. That means if the bodies were released initially from rest, their acceleration, this acceleration of center of mass is 0, their velocity of center of mass is also 0. Both of them will be having equal momentum. Now let us extend it further. We know that if two bodies move with equal momentum, if their masses are equal, then kinetic energies also will be equal. If their masses are different, then their kinetic energies will be different. If we say that they are different, one should be having more value than the other. Which one will have more value? We know that if two bodies of unequal masses move with equal momentum, then latter body will have more kinetic energy. So here the two bodies are released. They start moving towards each other. At any instant, the forces exerted by them are equal and opposite. Their momenta are also equal and opposite, but their accelerations are different. Accelerations are in the inverse ratio of masses. Their velocities are also in the inverse ratio of masses, and their kinetic energies are also in the inverse ratio of masses. After this, let us consider some problems involving this formula: F is equal to G m1 m2 by r square.